Okay, so getting back to our linked list, we have defined a hex. So instead of being a big chunk of memories, let's cancel this. Hex is going to represent a bunch of the value of hex is going to be allocated in memories in all different kinds of chunks. So you can have chunks here and then another chunks here and another chunks later to, let's say, a use case where it would just be like x n. So the length of the linked list doesn't really matter because the way we are going to write this is, now that we understand how the values of hex is going to be stored in memories, we are going to use C++ language, which comes very handy when it comes to break around stuff and playing with memories of your computers. So we are going to use the C++ language to build a linked list. I'm going to dive into code a little bit further inside of this lesson, but before going too deep inside of the code, let's basically express and explain and explore on how we would be able to refer this part of hex to this part, to this part, to this part. Because let's say as a user we are requesting hex, then the computer needs to know that this refers to this, to this, to this, to this, and to this, and not only to this node, right? So if example x in this use case, let's say represent my name, which is Antoine, then say every letter is x1, x2, and so on. So x1 would be something like A, my first letter, and so on and so on. So like every letter is a certain values of the node. Well, if I'm requesting my name, the computer needs to throw hex as Antoine in one chunk, while the way we are treating this is by separating every character as a node of our linked list, right? Basic stuff right now. So let's continue to say we have we have x, and being A N T O E N E, which is just our chunks inside of our memories. So every chunks in memories refers to a letter pointing each other to each other, right? So in C++, what we're going to do is we're going to use and to build the linked list with something like every hex. So let's say for every hand of x, so x1 is going to be a struct. So we're going to say struct, and we're going to say that this struct is going to have let's just say hint values or char values, but let's say just a hint values for now. So it's going to have a hint values. It's also going to have the next address in memories, right? So every node, so let's say this node is going to have a value, but is also going to be, every node of this linked list is going to have a pointers referring to the address of the next node. So when we are going to access hex being linked list, we're going to be able to say value of x1, say hey, and then have another x1 values, which is going to be the address of hex2 that is going to have the same thing. So hex2 will have the hex2 value and the x3, which is the next node, so x next node address. So this way, when we're going to call our linked list, we're going to be able to say, so hex is going to be calling the first node, which have a value, and is going to be calling the next value of this node that refers to the address of the next node in the list that has a value and an address. So value of node 2 and address of next node, right? So we call the address of next node, which have the same thing, and so on and so on. So this way, the way computer is going to interpret hex is going to be Antoine, and Antoine is going to be break inside all different nodes that have a value and an address, memories, pointers to the next node, right? Kind of basic stuff.